We all think we know the story of creation, right? For our entire lives, it's been the same epic tale. 13.8 billion years ago, everything, all of space and all of time, burst into existence with the Big Bang. This isn't just a good story. It's the bedrock of cosmology, the standard model. But what if that wasn't the real beginning? The James Webb Space Telescope, humanity's golden eye on the cosmos, is peering back to the dawn of time. And it has found something that, according to our best theories, simply shouldn't be there. JWST has spotted a handful of galaxies that are so ancient, so massive, and surprisingly grown up that they're forcing scientists to ask a mind-bending question. Is the neat story of our universe's origin missing a chapter? Now, to be clear, the idea that fully formed galaxies existed before the Big Bang is not what most scientists think is happening. But these discoveries are a genuine scientific puzzle that could rewrite everything we know about how the universe got its start. To get why this is such a shock, let's quickly recap the official story. It's called the Lambda Cold Dark Matter Model, Lambda CDM for short. And for decades, it's been brilliant at explaining almost everything we see in the cosmos. The story starts 13.8 billion years ago. The universe wasn't empty space. There was no space or time. Then, bang. The Big Bang wasn't an explosion in space, but the expansion of space itself, from a point of unimaginable heat and density. In the first few 100,000 years, the universe was a hot, dense soup of particles. As it expanded, it cooled, and gravity got to work. The theory predicted that gravity, with a helping hand from huge invisible scaffolds of so-called dark matter, would slowly pull together the first wisps of gas. This was meant to be a slow-motion construction project. Over hundreds of millions of years, little clumps of matter would form, then merge into bigger clumps. These would become the first dinky little proto-galaxies. According to this model, the first billion years should be full of small, dim, and messy star collections. Big, orderly galaxies like our own Milky Way were thought to take billions of years to build. Finding a massive, mature-looking galaxy in the cosmic dawn would be like finding a fully lit skyscraper in what you thought was the world's first hunter-gatherer village. It just shouldn't be possible. And then we pointed Webb at the dark. Launched in late 2021, the James Webb Space Telescope is a time machine. Its powerful infrared eyes can see light that's been traveling for over 13.5 billion years. It was designed to witness the cosmic dawn, the era when the very first galaxies were supposed to be switching on. And it saw something way more spectacular. In a survey called the JWST Advanced Deep Extragalactic Survey, JADES for short, astronomers found what broke the record for the most distant galaxy ever seen. Say hello to JADES GS Z14-0. We're seeing it as it was just 290 to 300 million years after the Big Bang. That alone is incredible. But it's the nature of this galaxy and others like it that's causing a stir. JADES GS Z14-0 isn't a faint smudge. It's shockingly bright and surprisingly big, measuring over 1,600 light-years across. Its brightness suggests it's packed with hundreds of millions of suns worth of mass, mostly in brilliant young stars. The question bugging astronomers is, how did the universe build something so big, so fast? And it's not alone. JWST has found a whole population of these unexpectedly bright and massive early galaxies, way more than the handful that models predicted. Some are so shockingly mature, they've been nicknamed universe breakers. They are too big, too bright, too well-formed, and they showed up way too early to the party. They are, for all intents and purposes, the impossible galaxies.
When faced with evidence like this, science doesn't panic. It gets to work.
The discovery of these impossible galaxies hasn't made most scientists want to scrap the Big Bang theory. Instead, it's kicked off a scramble to figure out if the rulebook for building galaxies was totally different in the early universe. The leading idea is that our models were just wrong. Maybe turning gas into stars was way more efficient and explosive back then. Some newer simulations suggest early galaxies grew in rapid, brilliant bursts, which could make them look brighter and more massive than they really are. Another possibility is that some of the light isn't from stars at all, but from gas being swallowed by supermassive black holes at the galaxy's centers, creating a kind of optical illusion. But even these ideas are struggling to explain the sheer number of these cosmic oddities. This has pushed some scientists to question more fundamental parts of the standard model. For example, a few researchers have pointed out that these findings challenge the role of cold dark matter. Remarkably, these big, bright galaxies are more consistent with predictions made by a controversial alternative theory of gravity called modified Newtonian dynamics, or MOND. This theory suggests gravity works differently on galactic scales, allowing galaxies to form much faster without any dark matter at all. MOND is definitely a minority view and has its own set of problems, but the fact that it's even in the conversation shows how seriously this new data is being taken. We are watching the scientific method play out in real time. The observations are solid, so now the theories have to adapt or die. So, what if tweaking the models isn't enough? This is where the story takes a turn into the truly profound. What if these galaxies aren't just signs of rapid growth after the Big Bang, but are somehow connected to something that came before? Let's be very clear, this is not a mainstream scientific view, but it's an idea that's been kicking around theoretical physics for years, and JWST's discoveries have given it a new spark of relevance. The most famous of these is from Nobel laureate Roger Penrose, and it's called conformal cyclic cosmology, or CCC. Penrose's theory proposes that our universe is just one in an endless series of cycles, or eons. An eon starts with a Big Bang, expands, forms stars and galaxies, and then, over trillions of years, all matter gets swallowed up by black holes. Those black holes then evaporate via Hawking radiation, leaving behind a cold, empty universe of pure energy. Here's the genius part. At that final moment, a universe that's infinitely large and empty is geometrically identical to one that's infinitely small and dense. The end of one eon seamlessly becomes the Big Bang of the next. The Big Bang isn't a one-time creation event, but more of a cosmic transition. Penrose even predicts we might find faint Hawking points in the afterglow of the Big Bang, ghostly echoes from the black holes of the previous eon. While no conclusive evidence for these points has been found, it provides a stunning alternative way to think about the cosmos. This isn't the only idea out there. Other theories propose a big bounce from a previously collapsing universe. These are speculative, deep ideas on the very edge of testable science. But the impossible galaxies from JWST are exactly the kind of beautiful anomaly that pushes scientists to consider such radical possibilities. If galaxies didn't have enough time to form in our universe, you have to at least ask, could their seeds have been planted in one that came before? The James Webb Space Telescope isn't just taking pretty pictures, it's challenging the foundations of our cosmic story. We are living through a potential revolution in cosmology, where a few faint red dots of light are forcing us to ask questions about the beginning of time itself. What do you think is going on? Is this just a simple flaw in our models, or a clue to a universe that existed before our own? Let me know your thoughts in the comments below. And if you want to stay on the front lines of cosmic discovery, make sure to subscribe and ring that notification bell. So, have we proven that galaxies existed before the Big Bang? Absolutely not. For now, the more likely explanation is that our understanding of how galaxies grow is incomplete. The early universe might have been a much more efficient and wild star factory than we ever gave it credit for. But the book on creation is no longer gathering dust on a shelf. The James Webb Space Telescope has presented us with a beautiful paradox. It has shown us things that by our current rules shouldn't exist. And in science, a paradox isn't a failure, it's an invitation. It's a crack in the wall of our knowledge, and when we peer through it, we're starting to see the outlines of a cosmos that is far stranger, more complex, and more magnificent than we ever dared to imagine. The story of the universe isn't over. It might just be getting to the good part.